We press collect. So we go inside. Then we take a measurement. Let's press data mark. Then let's go out about 1 centimeter. Data mark. Then another one, data mark. Then let's have this one, data mark. 1 more centimeter. Another data mark. Another one. Data mark. Let's go here. So we're almost about 0.01, but still higher. Then let's go back. So we can see here that we are below 0.01 millitesla. So that means we need to decrease the resolution that we have here on the magnetic field sensor. So for now, we reach 42. Let's collect these numbers that we have collected. So we have here, there's the first one in the middle, then centimeter, second, third. Let's get this one. What is this? Yeah. Then we need to collect these values, basically from the beginning and so on. So the center, it is 0. So let's have a new sheet. Let's basically, the distance is in centimeter, and we have the magnetic field, millitesla. Let's copy this one. I prepared it before. So we have this one. So let's see. So we have 0 basically. We are going to record up to 20 centimeters. So we are going to record from 0 to 20. So let's have this one. Then let's see what the first value that we have collected. It was minus 3.17. Then the second one, it was minus 1.92 millitesla. Then we have minus 0.85 millitesla. Then we have minus 0.28 millitesla. Then we go down. It is minus 0.111. Then minus 0.033. Then basically this was minus 0.025. And this is the location, which basically here in this graph it's 34. So our next is going to be 42. Let's reduce the range to have higher sensitivity. Use sensor setting. Then basically we'll make this one again, let's say 60s, and this 120. Okay, no problem. After that, we need to close the power supply so that the magnetic field is gone. Then after that, we need to go to the experiment and 0 the sensor. So it's 0 right now. Then after that, we need to open again the power supply to supply the circuit with 0.3 milliampere. Then we press collect at 42 centimeter. Collect other one. Then up to 30. And stop this one. The power supply, the experiment is done. We need to collect the data itself that we have given, we have recorded. So let's organize it first. So let's have them. So 7 centimeter. So we have minus 0.025, minus 0.018, minus 0.012, minus 0.0074, minus 0.0043, then minus 0.00002, and basically, and we keep going until we reach 20. Then we will do the calculations later. So now we are going to do the analysis itself. So these are the collected values at different distances, 0, 1, up to 20 centimeters from the middle of the solenoid. And these are the magnetic field measured. Basically, the negative sign means it's like in the opposite direction. So if you went to the other direction of the solenoid, it's going to give you a positive values for the sign itself. So anyway, I basically, after collecting all the data from the measured values, I converted the distance from centimeter to be meters. So basically we have this in meter, and this one becomes magnetic field in Tesla instead of milli Tesla here. Okay. Then after that, we can see from the manual itself, we have this, the magnetic field is equal to the permeability multiplied by number of turns, current, and the median or the average radius of the solenoid, which basically it's going to be the middle part between the inner diameter and outer diameter, over 2. Z is the distance from the middle and on the axis, and R squared the same as we said. So right now we would like to calculate the BZ itself. Okay. So here we collected these values. For my solenoid, it had 400 turns. We used 300 milliampere, and the 2L, which is the length of the solenoid, it was 4 centimeters. We have it's 0.04 meters. Then basically the inner diameter was 1 centimeter and the outer diameter was 2 centimeters, and the permeability value in space, or free space, is going to be this value. And basically we calculated the R, which is the median radius, which basically is the summation of the two radiuses over 2. So we have this one. So basically from this we can see that in this formula we have everything here except the Z itself. Okay, so let's first compute this constant, mu naught n R squared over 2. So we can see I call it constant without current. So this is basically the value of this constant, and with the current it's going to equal to this value, which basically calculating everything except this value, the Z squared plus R squared to the power 3 over 2. So once we have these two constants, basically we need to compute this value, okay, this Z squared plus R squared to the power 3 over 2. So we come here, we see that I have it here basically. You can see that this is kind of the distance squared plus the median radius squared, all to the power minus 3 over 2. So we have it here. So once we have this one, and we have the constant that we measured here, we can basically calculate the theoretical or the actual BZ. or the magnetic field using the actual distances from the middle of the solenoid. So this is the theoretical magnetic field using the equation, this equation, and this is a measured magnetic field. After doing this, I would like to plot the measured one and the calculated one. So from here we have plotted basically the magnetic field with the axial position z squared plus I squared to the power minus 3 over 2. So we have this one, this is a measured magnetic field, and this is the actual magnetic field. And as we said, the sign or the negative sign here basically means that it depends on the measurements. We are measuring from the north side of the solenoid or the magnetic field or the south side. Okay. Then from here we have also plotted the measured magnetic field with respect to distance. So this is going to be the distance from the middle of the solenoid itself. So now we need to get the tail of the curve. So I'm going to say that, okay, the tail is going to start from 0.05 from here till the end. So from this value till the end, and basically it is from 0.05, which is basically this portion of the curve. When we get this curve and we just plot from 0.05 or 5 centimeters from the middle of the solenoid up to the 20 centimeters, we can have this curve. And basically this is the curve that we need to use to find what is the power function that could fit within this curve. Okay, so in the next video we are going to introduce how to find the power of this curve that could fit this tail part of the magnetic field. I hope this lab was beneficial for you. So if you like it, please press like and share and subscribe for the channel to receive the next lab. And wait for our next lab in Physics 2. Thank you.